Hello everyone! Welcome to Mathematics 10. I am your teacher, Sir Pablo Alberio Jr. Are you ready to learn something new today? If yes, then please have with you your pen, notebook, and module, and we will start with our discussion. I want you to look around your surrounding. Look, what will you see? Yes, of course. You saw the beauty of nature. You saw houses, road, cars, and people. Now, what is your observation with those things that you saw? Yes, very good. It has colors, shapes, and patterns. We use the colors, shapes, and patterns in identifying the things around us. So, can you now guess what is our topic today? Yes, very good. Today, we will learn about the generating patterns. So before that, let us have first our lesson objectives. At the end of this lesson, you are able to first generate patterns, second, cite situation that generate patterns, third, illustrate patterns in a relationship, fourth, appreciate the significance of pattern in the day-to-day lives. So patterns can be found in the nature, in an object, or in a number sequence, which is our focus for this lesson. Let's have the unlocking of terms. First is pattern. Constitute a set of numbers or objects in which all the members are related with each other by a specific rule. Next, sequences. A sequence is a function whose domain is the finite set 1, 2, 3, n or the infinite set 1, 2, 3, . For instance, we have these two sets of sequence. For sequence A is a finite set because it has a last term which is 32. Sequence A have 16, 20, 24, 28, and 32 which is the last term. While sequence B is an infinite sequence because it has no last term, which means it continues infinitely. Sequence B have 16, 20, 24, 28, 32, ... or infinite. Now let us try our preliminary activities. What is the next polygon in the pattern shown below? The first polygon is a triangle which have 3 sides. The second polygon is a quadrilateral which have 4 sides. The third polygon is a pentagon which have 5 sides. Then the fourth polygon is a heptagon which have 6 sides. Then the fifth polygon is a heptagon having 7 sides. Now what is the next polygon after our heptagon? Yes, the correct answer is an octagon which have 8 sides, which means that the pattern is illustrated that in the succeeding polygon, the sides increase with one side in the next polygon. So in our next activity, we will try a number sequence. So what is the next number? First, we have 0. Second, we have 4. Third, we have 8. Then fourth, we have 12. Fifth, we have 16. And then, what is the next number after our 16? Yes, very good. The correct answer is 20. Now, what is the pattern in this number sequence? Yes, very good. We just add 4 to get the next term. So from 0, we add 4 to get our second term, which is 4. From 4, we add 4 to get the third term, which is 8. From 8, we add 4 to get the fourth term, which is 12. From 12, we add 4 to get our fifth term, which is 16. From 16, we add 4 to get our sixth term, which is 20. How about this one? What is the next number? So the first term is 10. The second term is 8. The third term is 6. The fourth term is 4. The fifth term is 2. The sixth term is 0. The seventh term is -2. The eighth term is -4. The ninth term is -6. Now, what is the next number after -6? Yes, the correct answer is -8. Now, what is the pattern in this number sequence? Yes, very good. We subtract we subtract 2 from the prior number, so we get the preceding number. So from 10, we subtract 2 to get 8. From 8, we subtract 2 to get 6. From 6, we subtract 2 to get 4. From 4, we subtract 2 to get 2. From 2, we subtract 2 to get 0. From 0, we subtract 2 to get -2. From -2, we subtract 2 to get -4. From -4, we subtract 2 to get -6. From -6, we subtract 2 to get -8. So that's it. Next, what is the next number? The first term is 1. The second term is 4. The third term is 9. The fourth term is 16. The fifth term is 25. Now, what is the next number after 25? Yes, correct. The next number is 6. Now, what is the pattern in this number sequence? Yes, very good. The pattern is each term is a perfect square. So for example, this one, number 1. So 1 times 1 is 1. 2 times 2 is 4. So the third term is 3 times 3 is 9. Then the fourth term is 4 times 4 is 16. Then the fifth term is 5 times 5 is 25. And then 6 times 6 is equal to 36. So they are all perfect square. Next, what is the next letter? So the first letter is letter A. The second letter is letter E. The third letter is letter I. The fourth letter is letter M. The fifth letter is letter Q. Now, what is the next letter after Q? Yes, very good. U. So what is the pattern? Very good. The pattern is we skip 3 letters to get the preceding letter. So from A, we skip B, C, and D to get E. From E, we skipped F, G, H to get I. From I, we skipped J, K, L to get M. From M, we skipped N, O, P to get Q. From Q, we skipped R, S, T to get U. So that's it. So now let us discuss the position of the term. So let us have the position of the term. So our sequence is 3, 6, 9, 12, 15, and then 18. So 3 is our what? Our A sub 1. Then 6 is our A sub 2. Then 9 is our A sub 3. 12 is our A sub 4. Then 15 is our A sub 5. Then 18 is our A sub 6. So you have it. Our 3 is A sub 1, 6 is A sub 2, 9 is A sub 3, 12 is A sub 4, 15 is A sub 5, and then 16 or 18 is A sub 6. So A sub 1 is the first term. A sub 2 is the second term. A sub 3 is the third term. A sub 4 is the fourth term. A sub 5 is the fifth term. And then A sub 6 is the sixth term. Now, we have this, the base and subscript. So from our A sub 1, A is our base and then 1 is our subscript. Kanang gamay dira nga. Kung mugamay gani siya sa ubos, that is subscript. So A sub 1, that is being or basahon siya as A sub 1. Now let's try the n term. What is the first 5 term of the sequence? A sub n is equal to 3 times n plus 5. So A sub n is equal to 3 times n plus 5 is our specific rule. So we will use that equation in solving the 5 terms. So first, we need to solve our A sub 1. So A sub 1 is equal to 3 times, we substitute 1 from our n. So in our 3 times n, we also substitute our n with 1. So 3 times 1 plus 5. Then perform the operation. So A sub 1 is equal to 3 times 1 is equal to 3 plus 5. So A sub 1 is equal to 8. Our first term is 8. Next, we need to solve our A sub 2. So we will still use the specific rule. A sub n is equal to 3 times n plus 5. So we substitute n by 2. So A sub 2 is equal to 3 times 2 because we need also to substitute the same number with our n here with 2. then plus 5. So perform the operation. A sub 2 is equal to 3 times 2 is equal to 6 plus 5. So A sub 2 is equal to 11. Our second term is 11. Next, we need to solve our A sub 3. We will still use the same specific rule. So A sub 3 is equal to 3 times 3. The value of our n is 3 plus 5. Then perform the operation. A sub 3 is equal to 3 times 3 is equal to 9 plus 5. Then add. A sub 3 is equal to 9 plus 5 is equal to 14. Our third term is 14. Next, we need to solve our fourth term. So A sub 4 is equal to 3 times 4 plus 5. A sub 4 is equal to 3 times 4 is equal to 12 plus 5. Then A sub 4 is equal to 12 plus 5 is equal to 17. Our fourth term is 17. Then, the last term we need to compute is A sub 5. So, A sub 5 is equal to 3 times 5 because we substitute n with 5. So, in our 3 times n, we need to substitute n by 5 plus 5. Then, A sub 5 is equal to 3 times 5 is equal to 15 plus 5. Or A sub 5 is equal to 15 plus 5 is equal to 20. Now, the 5 terms are, so this is the standard form in writing our sequence. We need to put comma in each term. So 8, 11, 14, 17, then 20. So our 5 terms are 8, 11, 14, 17, and 20. Okay, another example. What is the first 4 terms of the sequence? A sub n is equal to 2 raised to the power of n. So, we solve first the first term, A sub 1. So, we need to use our specific rule. A sub n is equal to 2 raised to the power of n. Then, substitute n by 1. So, A sub 1 is equal to 2 raised to the power of 1. Or, A sub 1 is equal to 2. Next, we need to solve our second term. A sub 2 is equal to 2 raised to the power of 2. Or A sub 2 is equal to 2 times 2 because we are talking here with power. So, naka-exponent man siya. So, dapat ato siyang i-multiply. The base will be multiplied twice. Kaduha. So, 2 times 2. Or A sub 2 is equal to negative, or is equal to 4. Sorry. A sub 2 is equal to 4. Then we need to solve our third term. Again, we still have to use our specific rule. A sub n is equal to 2 raised to the power of n. So A sub 3, we substitute n by 3 is equal to 2 raised to the power of 3. So we also substitute here n with 3. So that will become A sub 3 is equal to 2 times 2 times 2 times 2 because we are talking here about exponent. So, which means 2 raised to the power of 3 or 2 will be multiplied 3 times. That will become A sub 3 is equal to 8. Then, we also need to solve our fourth term. So, A sub 4 is equal to 2 raised to the power of 4. The value of n is 4. Then, we have A sub 4 is equal to 2 times 2 times 2 times 2. Because our exponent is 4. Then that is A sub 4 is equal to 16. Now, we will write our 4 terms. So the 4 terms are 2, 4, 8, and 16. That is how the number sequence is being written. So that is the correct format. So that's it.